Hello. In this video, we'll talk more about quadratic equations and inequalities. So we have a few examples or let's say questions and additional exercises. So we are going to solve those problems in this video. So we have around 12 questions, I guess. Have a look as we have 10 questions. And all right. So let's start with the first question. In this question, a root of 2x squared minus 5mx plus 2m squared is equal to 5 is an integer. It says a root, not all roots, right? Only one of the roots. Find all possible integer values of m. Okay, so that is a quadratic equation, and the coefficient of x squared is 2. All right, so to find the solution of the quadratic equation, we know that we will use discriminant, right? The first step. So first we need to find the discriminant of this quadratic equation. So here, before this, let me just write this in standard form. Here we have 2x squared minus 5mx plus 2m squared minus 5 is equal to 0. So here the coefficient a is equal to 2, coefficient b is equal to negative 5m, and coefficient c is equal to 2m squared minus 5. Here m is a parameter, x is the unknown number. So what is the discriminant of this quadratic equation? That's equal to negative 5m squared minus 4 times 2 times, so 4 times a times c, that is 2m squared minus 5, right? So if you simplify this, here we have 25m squared, and 4 times 2 is 8, 8 times 2 is minus 16, that is m squared, plus 4 times 2 times 5, that's equal to 8, that's equal to 40. Or here we have 9m squared plus 40. Okay. So actually it's always positive, and m is an integer, right? And also the root is integer. Okay, here if you try to find the root, for example, let's say that's the first root. What is it? That's equal to minus b. That's 5m plus square root of 9m squared plus 40 over, and here we have 2 times 2, that's equal to 4. And how about the second root? That's equal to 5m minus square root of 9m squared plus 40 over, and here we have 4. Okay, so in this question, a root of 2x squared, right? It is an integer, and find all possible integer values of m. Here also actually one of the roots, maybe alpha or beta, that is integer, right? And also m is integer. Now from here, what is it? This 9m squared plus 40, this m is integer, and integer plus square root of something, that is 4, right? And to be this roots, one of them, it doesn't matter, right? To be integer, also square root of 9m squared plus 40 must be integer, right? So for integer, we know that, for example, that means that so that means that this 9m squared plus 40, it should be equal to some numbers, what is it? Square, right? Because to take this out of the square root, right, 9m squared plus 40, it must be equal to a perfect square. So immediately, just a little bit observation, right? It gives us that this 9m squared plus 40, what is the closest what is it, square number? So as I see here, if m is equal to plus minus 1, at the time here we have 9 times 1 plus 40, that's equal to 49. So we can get the answer here. Alpha will be equal to 5 times, if m is equal to 1, right? It is 1 plus, and the square root of 49, that's equal to 7 over 4. That's equal to, let me just write here, m equals 1 here, the first condition. If m equals 1 is 12, that's equal to 3. And the second one, we don't even have to find, just I want to make sure that actually one of the roots is integer. So if m is equal to negative 1 here, right? Here we have alpha again. Here we have alpha will be equal to 5 times -1 plus 7 over 4 and minus 5 plus 7. That's equal to, what is it? Minus, it is 2. 2 over 4, that's not. But that's why I'm not going to use the second root here, beta. So that's just, let me use minus here. Minus 5, minus 7, minus 12. So the answer is -3. So that is integer and that's integer. So here, now find all possible integer values of m. What is it? So that's m is equal to 1 or m is equal to -1. Okay. So you may actually wonder, how do we know that other values of m does not satisfy or do not satisfy these conditions? And here we have, if you see that actually k squared, right, is equal to 9m squared plus 40, right? And if you just take this 9m squared to the right hand side, so at the time this k squared minus 9m squared, right, you can just factorize this. K times I can just write here, for example, let's say, just here we can write here k squared minus 9m squared, that's equal to 40. That's a bit long way. Then on the right hand side, I have k minus 3m and k plus 3m. On the right hand side, we have 40, right? K is integer, right? And also m is integer. So what actually are the possible ways to write 40 as a product of two numbers? So k minus 3am, k plus 3m, right? So I can just make a table here then. K plus 3m, that's equal to maybe minus 1, minus 40, or 1, 40, or 40, 1, or minus 40, minus 1, or 2 times 20, and blah, blah, blah. All right. We can just make a list, and when you just actually check this out, the only it works here is when m is equal to 1 and m equals -1. We have only one other solution. Otherwise, because we'll have a system of two linear equations where k minus 3m is equal to the factor of 40, right? Let's say it's -1. At the time, k plus 3m should be equal to minus 40. So to find m, right, we need to subtract. So if you just subtract these equations from each other, at the time we will have here 3m minus 3m, we will have 6m, right? On the right hand side, we will have the sum of these numbers, like -1 minus 40, or 140, or 41 minus 40 minus 1, right? Actually, none of them is divisible by 6. Actually, at the time, it does not give us integer value of m. The only case one is divisible by 6 is when it is like, what is it? 41, actually 2 times 20, 5 times 8, 8 times 5, 4 times 10, right? It's only is when it is like 4, 10, or 10, 4, or -4, -10, because if you just add them, okay, it's 20 minus 22 plus 22. Okay, so when we just subtract them, right? 4 minus 10, for example, it is 6. 10 minus 4, it is 6. Or 20 minus 2, and 20 minus 2, and also, yeah, that's it. Anyway, when you just solve this, then at the time you can get the answer m is equal to 1 and m equals -1. Okay, so that is one way of solving this one, because I just want to keep the to save the time. I'm not going to consider all of these cases. So immediately you can just check, for example, another square number, you will see that it doesn't work. Next square number is, what is it? After 40, that is 64. For 64, 9m squared should be equal to, what is it? It is 64 minus 40, that's 24. So 24 is not divisible by 9. Next square number is 81. 81 minus 40, that's equal to 51, not divisible by 9. Next square number is 100. 100 minus 40, it is 60. Also, it does not work, right? Also, in general way, we can just prove in this way. Anyway, let's move to another question. In this question, the roots of x squared minus 21x plus t is equal to 0 are a and b, where both are prime numbers. Find the value of a, b over a plus a over b. Okay. Since actually they are prime numbers and these are the roots, right? And let's see here, what is this 21? This 21 should be equal to a plus b. These are the roots, right? So here we have a plus b, it should be equal to 21. And the a times b, it should be equal to, what is it? it should be equal to t. Okay, so the sum of the roots of the equation and the product of the roots of this equation that we studied in the first part of this video series. So now we're going to determine the values of a and b. Since a and b are what is it? They are prime numbers, right? So the first possible answer is the smallest prime number is 2. So if a is equal to 2, b should be equal to 19, right? And 2 and 19, they are prime numbers. So also actually 19 and 2, I can write this, but actually it does not make any contribution to evaluate this expression. That's why, because a over b, b over a, that is 2 over 19 plus 90 over 2. If you just interchange the places, it gives us the same result. That's why we are not going to rewrite the other pair of these numbers like 19 over 2. Just skip this. Another one is, for example, next prime number is 3, right? If it is 3, and this b should be 18. 18 is not a prime number. 3 doesn't work. If it is 5 plus 16, it doesn't work. Next prime number is 7 plus 14 is not a prime number. Next number is 11. If it is 11, 10. So for other numbers also it does not work. So the only possible answer here is a is 2, b is 19, or a is 19, b is 10. So now using these values, if you evaluate the expression a over b plus b over a, that's equal to 2 over 19 plus 19 over 10, right? So if you simplify this, the common denominator is 2 times 19, it is 38. 2 times 2, it is 4. And 19 times 19, that's equal to 361. So the answer is 365 over 38. All right. Next question. The roots of x squared plus px plus 1997, 1997 is equal to 0 are a and b, where both are positive integers. So a and b are positive integers. So we need to find the value of this expression, p over a plus b, a plus 1 times b plus 1. So suppose that actually it's already given a and b are both positive integers and they are the roots of the equation. So from the first video, right, I can just write here the sum of the roots of this equation. It's already in standard form, right? That's equal to minus p. And also a times b, that's equal to 1997. And actually this 1997, right, that we just write here, 1997 is a prime number. It's a prime number because 1997, 2017, right? And anyways, it's 199. So it's the prime number. So that means that what are the possible values of a and b? So since both are positive integers, I can just write here them positive integers, possible values of a. If a is equal to 1, b should be equal to 1997. If b is equal to 1997, then a should be equal to 1. In both cases, then here we have, or is it the sum does not change? What is p here then? P is equal to minus a plus p. That's equal to minus a plus b is equal to, what is it? 1998. Okay. So now in the second step, we are going to evaluate the given expression. That's equal to, okay, here we have p over a plus 1. And here we have p plus 1 is equal to, we know the value of p, that's equal to minus 1998 over, and here we have a times b. A times b is 1997 plus, and here we have, if you open the brackets, here we have a times 1 and b times 1, that's a plus b. What is a plus b? A plus b is minus 1998 and plus, and here we have 1. 1 times 1 is equal to 1. So a times b, that's equal to 1997, and a plus b, that's equal to a plus b, a plus b. Okay, a plus b is equal to minus p, right? So a plus b A plus B is just 19998. Okay, sorry, that's equal to 1. All right, that minus 1998, and here we have plus 1. So here we have 1997 plus 1, that's equal to 1998, right? And here we have minus 1998 over 2 times 1998. So the answer is 1 over 2. Okay, so, okay, that's it. So the result is negative 1 over 2. Okay, question 4. If the roots of x squared plus mx plus 1596 is equal to 0, are both integers. That means including positive and negative. Find the number of possible values of m. Okay, so now it says that both are integers, right? And from here, suppose that alpha and beta are the roots of the equation. At the time here we have alpha plus beta is equal to minus p, right? And alpha times beta is equal to 1596. We can write this relationship, right? Since actually m is if the roots of, okay, since both roots are integers, that is alpha and beta. Let me just write here alpha and beta, both are integers, right? And from here, and also actually we can get that m also must be integer, because the sum of two integers, that is an integer number, and also the product of two integer numbers, that is also integer. Now from here, we are sure that m is integer. Okay, so next thing is, so a plus b equals minus m, right? So a times b equals 1596, right? So actually here, let me draw a line. Let me draw a line here. All right. So that's our first step. And the second step, let me change the color here. So a times b equals 1596, right? What is 1596? Immediately we can just write here 1596, right? If you just divide by 2, 1596 divided by 2, that's equal to 799. And it's not divisible by 2, divided by 3, it is 2, 6, is divided, okay, 19, okay, 18, 799. If you divide by, okay, 3, okay, 7, 19, 9, 16, okay, it should be 8, right? Okay, this should be 8. So still we can divide by 2. Okay, if you divide by 2, 7 is divided by 2, it is 3, 19, it is 9, 18, it is 9. So 399 is not divisible by 2 anymore. Divided by 3, it is 133. And 133 is not divisible by 3, it's not divisible by 5, so it's divisible by 7. So the answer is 19. 19 is a prime number, so it's equal to 1. So what I'm trying to do here is, I'm just going to write the factors of this 159. So the factors are, what is it? The factors are 1, it is 2, and the 4, right? 2 times 3 is 6, and what is it? And after that it is 7, and after that, what is it? 7, 3 times 4 it is 12, and okay, 3 times 7 is equal to 21, and it is actually before 21 we have 19. 19 is also a factor. Okay, we have 19 and 21, right? And what are these? 2, okay, 2 times 2, 4, 2 times 3, 6. Okay, we have 7, and after that, 4 times 3, it is 12, and 3 times 7, 21, it is 19, and 4 times 7, it is 28, right? And 3 times 7, 6 times 7, 42. Okay, let's just write here 42, and it is 84. I also need to write here 38, because 2 times 19, it is 38, and 42, right? Okay. 1, 2, 4, 6, 7, 12, 19, 21, 28, 38, 42. And after this, 3 times 19, it is 57. Okay, 57. And also here we have, what is it? All right. So okay, that's 1, 2, 1, 2, 3. Or 3, what did I? How can we skip 3 here? Okay, here we have 1, 2, 3, 4, 6, 7, 12, 2 times 7. Also here we have 14 and 19, 21, 28, 28 and 38, 42, 57 and 76 and 84, 84 and blah, blah. Okay, you can just write this. I'm not going to write all of them. All right. So here in another way, I can actually find the number of factors. Here should be, anyway, and yeah, if I need this later, I'll write this. Let me just write here, how many factors does it have? So the number of factors of this one, 1569. So I can write it as, so that's equal to 2 squared times 3 times 7 times 19, right? Number of factors is 2 plus 1 times 3 to the power of 1, 1 plus 1, 7 to the power of 1, 1 plus 1, 19 to the power of 1, 1 plus 1. Altogether, it has 3 times 2 times 2 times 2, that's equal to 24. It has 24 factors, okay? So this alpha and beta, right? I can just write this as, what is it? 24 factors. So 24, it is 12 pairs, right? So plus minus altogether, so it is 24. So this 1596, right? I can write in 24 different ways as a product of two integers, right? Like for example, 2 times remaining 1, right? And 3 times remaining 1 and blah, blah, blah. Okay, so also including negative, right? Negative numbers. So altogether we have 48. So the question and the answer to this part is we have 48 different values of m. So find the number of possible values of m, that is 48, right? Like for example, let's say, suppose if we have alpha times beta is equal to, let me just write here, what is it? Let's say this 6, right? So what are the factors of 6? It is 1, 2, 3, and 6. So the 6, I can write it as 1 times 6, 2 times 3, right? And also, okay, we have 1 times 2, 2 times 3, and 3 times 2. Okay, it gives us the same thing. So that is 1 times 6, 2 times 3, and here we have 3 times 2, and 6 times 1, right? So here we have 4, so we have 2 different ways. And also including the, what is it, negative numbers, it's not 48, and we have 24 different possible values of m we have here. Find the number of possible values of m. We have 24 possible values of m. Okay. By considering in number 4, the value of m gives the positive roots only. Okay. Find the sum of all possible values of m. So it says that in here, what is it? A plus b, right, is equal to negative m. Alpha plus beta is equal to negative m. Alpha times beta equals 1596. So in this question, again, we are talking about x squared plus, here we have x squared plus mx plus 1596. That is 1596. That's equal to 0. And number 4, the value of m gives the positive roots only. Right? So positive roots only means find the sum of all possible values of m. So when actually m gives the positive roots of this, so when an m is negative, right? If it is negative, so the negative m will be positive. So alpha is positive, beta is positive, right? So at that time, what will be, find the sum of all possible values of m. So what are the possible values of m? At the time, 1596, 1596, right? I can write it as 1 times 1596, or 2 times 798, 3 times, okay, first, if I just write the factors is 1, 2, 3, okay, 4, 6, and 7, right? 4, 6, 7, 12, 14, 12, 14, 19, 21, 19, 21, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Two more, 21. And after that, what do we have here? 28, 38, 28, and 38. And after the 38, we have 42, 42, and 57, 57, and 76, 76. And here we have 84, 84, 114, 114, and 133, 133, and 228, 228, and 266, and 399, and 532, 532. And 798, 798, and the number itself 1596. Okay. So here in the question, what is it? We know that's alpha times, or alpha plus beta is equal to minus m, right? And also here alpha is positive, beta is positive. So if it is positive, that means that m should be negative number. So that when you multiply negative number by minus, also it is positive, right? So alpha plus beta. By considering in number 4, the value of m gives the positive roots only. So when m gives positive roots, if it is negative, find the sum of all possible values of m. So alpha times beta is equal to 1596. So if alpha beta, right, it is positive, 1596, and the product and the sum. Okay. So let me just write the pairs of those numbers, okay? What are the possible values of m, right? So that means, let me just write here, when it is, we have 12 pairs, right? Minus 1, minus 1596, one pair. Another one is, what is 2 minus 2, minus 798, right? And minus 3, if it is minus 3, minus 532. And minus 4, positive roots. Okay. Anyway, these are 2, okay, 798. This 3, 4. One it is 4, right? 3, okay, there's 5. One is 3, 5, 3, 2. One is 4, 3, 9, 9. Okay. And when we have 6, right? If it is 6, 6, it is 2, 6, 6. It is 7, 2, 2, 8. If it is 12, 1, 3, 3. Now it is 14, 14, 1, 1, 4. Okay. 14, 1, 1, 4. Okay. And here we have 19, 84, and 21, 76, and 28, 57, and 38, 42. Okay. So these are all the possible positive roots of this equation, when actually they are integers, right? So what is it here? 1 plus 1596, right? And just actually m is negative, because when m is negative, the roots are positive. So I just need to add all of these numbers together, and after that multiply by -1. Okay. So what are these numbers? Actually 1, 2, 3, 4, 6, 7, 12, 14, 19, 21, 28, 38. The first columns, right? The second column is from the back, 42, 57, 76, 84, and 114, 133, 228, 266, blah, blah, blah. If you notice here, actually all of these numbers are, what is it? They are just all the factors of 1596. Okay. If actually 1596, once again, remember 1596, that's equal to 2 squared times 3, 7, 17, 3, 7, and 19, right? 3, 7, 19. So how do you find the sum of the factors of a natural number? So to do this one, we are just going to use actually this formula. S is equal to, the first one is 2 to the power of 2, right? So there's 2 plus 1 minus 1 over 2 minus 1. And the second one is 3 to the power of 1 plus 1 minus 1 over 3 minus 1 times 7 to the power of 1 plus 1 minus 1 over 7 minus 1, and 19, 1 plus 1 minus 1 over 19 minus 1. Okay, so now if you just add these numbers, just we need to calculate this. The first one is 8, 8 minus 1 is 7, so that's equal to 7. And second one is, it is 9 minus 1, 8, 8 over 2, that's equal to 4. Next one is 49, 49 minus 1 is 48, is divided by 6, that's equal to 8. Next number is 19 squared, that's equal to 361 minus 1 is 360 over 18, that's equal to 20. So the sum of all of these numbers will be, what is it? Is equal to 4480. Since actually it says that find the sum of all possible values of m, it must be negative, minus 4480. So this is the sum of all possible values of m, where it gives positive roots, or it produces positive roots of the quadratic equation. All right, another example, or let's say another question, question 6. The roots of x minus a times x minus 8 is equal to 1, are both integers. Find the value of a. Okay, here it says that's the roots, right? If you substitute something for x, if you substitute something for x, right, it must be equal to 1. Both are integers. So that means that x minus 8, since x is integer, right, x minus 8 is integer. And also if it is on the right hand side, we have integer. Also x minus a, if it is integer, a can be, okay, all right. Also it should be integer, right? So at the time, the only number where is equal to, because this one is integer, right? And we have integer, and also this x is integer. When it's integer, then it's equal to 1, right? So all right. So the only solution is a should be equal to 8. Anyway, first, let me just write also in this way. If you expand this, what we have here, x squared minus 8x minus 8x. So here we have a plus 8x. And here we have minus 8 times minus 8, that's equal to plus 8a. Take one to the left hand side, minus 1, that's equal to 0, right? So it says that both roots are integers. That means that here we have alpha plus beta. Let's say alpha and beta are integer roots of this quadratic equation. So that's equal to a plus 8. Okay. And here we have alpha times beta. That's equal to 8a minus 1. And since alpha and beta, they are integers, a plus 8, it must be integer. So which means that also a is integer. And also alpha times beta is integer. So 8 times a minus 1 integer. So a must be integer. Okay. So from here, then, what is this? This is the first observation, the second one. And the product of two integers is equal to 1. So what we have here is either x minus a is equal to 1, x minus 8 is equal to 1. Or x minus a is equal to negative 1, x minus 8 is equal to negative 1, right? We don't have any other way to write 1 as a product of two integers. It's either 1 times 1 or negative 1 times negative 1. From the first one, if you just subtract, right, that means that from here, right hand side are equal, x cancel each other. From here, what is a? A is equal to 8. And also from the second one, right, if you just subtract, right, and get the value of a, so what is a? A is equal to 8 again. So the only possible answer for a is, it is 8. Okay. Question 7. The two distinct roots, instead we have two roots and they are different from each other. Two distinct roots of the quadratic equation, a squared minus 2 times x squared minus 8ax plus 24 equals 0, are both negative integrals. Find the value of integer a. So the two distinct roots, right, they are both negative integrals, that means negative integers, and we need to find the value of integer a. Also a is integer. Okay. So, all right. Number one, from here, okay, suppose that alpha and beta are integral roots of this quadratic equation. This alpha and beta, okay, they are integer solutions of this quadratic equations. And also actually they are negative. So let me just write here minus. That means alpha and beta, they are negative integers. And also they are not equal to each other, right? So also we know that they are not equal to each other. So from here, we know that alpha plus beta, the sum of the root of the quadratic equation. What is it? That's equal to minus b over a. So that's equal to 8a over a squared minus 2, right? And how about the product? Alpha times beta, that's equal to 24 over a squared minus 2, minus b over a or c over a, right? Since alpha and beta, they are integers, right? So this a squared minus 2 from the second equation. So a squared minus 2, it must be a factor of 24. And also since alpha and beta are negative integers and their product is positive. So then what are the positive factors of 24? So actually they must be either 1 or 2 or 3 or 4 or 6 or 8 or 12 and 24, right? So that means that from here, if I just add, what are the possible values of a squared then? 1 plus 2, 3, 2 plus 2, 4, 3 plus 2, 5, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10, 12 plus 2, 14, 24 plus 2, it is 26, right? If I just take 2 to the right-hand side. So which of these numbers is a square number? Because on the left-hand side in the question it states that a is integer, integer squared, also the result is integer, right? So here we have only this 4 is a square number and none of the other numbers are square numbers. So the only possible value of a here is, what is it? plus minus 2. So when a is equal to plus or minus 2, right? And both of the roots of the equation, it will be negative. And also, if you just check this, the first one, right? Okay, I think we are not done yet. Okay, let's say this one is step number 2. And the step number 3, from this equation, right? Let me just write here I, and this one is double I, okay? And since alpha and beta are negative number, right? Also 8a over a squared minus 2, it must be negative number, right? A squared minus this, when a is plus minus 2 is positive, right? And also numerator a times a, it must be negative number. So if a is equal to 2, it will not be negative number, it will be positive number. And since the roots are negative numbers, then your sum is also negative number. So dot, dot, dot. So the possible value of a is only negative 2. If it is positive 2, the roots will not be negative. All right. Next question, question 8. The roots of x squared minus ax plus 4a is equal to 0 are both integral. Find the value of a. So we need to find the value of a. All right. Okay. So first observation is, again, if alpha and beta are roots of the equation, and this alpha and beta, they are integers, right? And find the value of a. Find the value of a. And second thing is, we know that alpha plus beta, that's equal to minus b, that is a, and alpha times beta, that's equal to 4a, right? So since alpha and beta integers, also a is integer, right? And of course, also 4a is integer. Let me draw a line. Okay. Okay, that's the first observation. Now continue. Since both are integers, let's find the discriminant first, because we know that for a quadratic equation to have two roots or real roots, right, the discriminant should be greater than or equal to 0. If it is equal to 0, it has two repeated roots, they are equal. If it is greater than 0, then two distinct real roots. So what is the discriminant here? It is b squared, that's a squared minus 4 times 4a, which is equal to a squared minus 16a. So now from here we can write the roots, right? Alpha is equal to a plus square root of a squared minus 16a over 2, right? And the second root is a minus square root of a squared minus 16a over 2. So for this roots alpha and beta to be integer, right? The square root of a squared minus 16a, it must be equal to, what is it? An integer. So that means that first we know that this a squared minus 16a, that's equal to a times 16 minus a, it should be greater than or equal to 0. So that means that here we have 0 and here we have 16, right? And we have solution only here, because here it is plus and here we have plus. So between 0 and 16, we don't have any solution here. So immediately, if I just check, okay, the first observation here, like let's say if a is equal to 16, what happens here? At the time, discriminant is equal to 0, right? So here we have alpha will be equal to, it is 0, is equal to 16 over 2, that's equal to 8. And also that's equal to beta. So 8 is integer, right? So we found one value of 8. Another value is, for example, how about for example, a times 16 minus a, when it is a perfect square number. So like, for example, if a is equal to, again, for example, let's say, all right. It's not, a is a common factor here. So this a minus 16, right? Okay. When a is greater than 16, it is positive. Less than 0, again, it is positive. Between 0 and 16, like for example, 5, it is negative. Okay. All right, so this a times a minus 16. So if a is equal to 18, right? Again, this command is equal to 18 times 2, that's equal to 36. So what is alpha? Then alpha is equal to, a is 18 plus 6 over 2, that's equal to 24, 12. How about beta? 18 minus 6 over 2, that's equal to 6. As you see here, 12 and 6, they are integral roots. So now we have two possible answers. Another way is, how about, for example, a is equal to 0. If a is equal to 0, right, again, this discriminant is equal to 0. And when it is 0, we have one answer, this 8. And how about if a is equal to negative 2, for example? If a is equal to negative 2, negative 2 times negative 18, the 36, the delta is equal to, what is it, 36. And also here we have these roots, right? So we have four possible answers then. Here we have a, all possible answers are, what is it, negative 2, 0, 16, and 18. Okay. Now, of course, immediately the question comes, but can it be this a squared minus 16a? Can it be equal to other perfect square numbers? Okay. So actually, it is not possible. Suppose that, for example, let's say a squared minus 16a. Okay. Let me just write. Okay. This brief explanation why actually it cannot have other solutions. Suppose that this a squared minus 16a, okay, is equal to some numbers square integer. Okay, let's say n is greater than 18. Because when it is 18, we have already considered that's the answer, right? So now from here, what do you see here? Here I can see that actually, what is it? Here we have a minus 16, right? On the right hand side, we have n squared. Okay. So suppose that it is greater than 18, right? So this n squared, I can just write it as n times n, right? So now actually here, these two numbers are different, all right? So if I just write it like, for example, n over 2 times 2n, right? This is how we actually, what is it, factorize a number if it is divisible by 2. If it is divisible by 3 at the time, n over 3 times 3n, or what is it, n over 4 times 4n, or n over 5 times 4, n over 5 times 5n. And I'm assuming that, suppose that n is divisible by 2. If it is not, at that time I can write it as n over 3. That's only way how to write a number as a product of two numbers, right? Now from here, if you find the difference here, what is 2n minus n over 2? So that's equal to 3 over 2 times n, right? So this n is greater than 18, right? It's greater than 3 over 2 times 18. That's equal to 27 here. But here, as you see here, the difference between these two numbers is 16. So if it is like 3n minus n over 3, the difference will be even higher. Okay. So that means that as the square numbers get bigger and bigger, and the difference between, if you just write it as a product of two numbers, and also difference will get bigger and bigger. Okay. So that's why actually it does not have any other solution. The only solutions are, what is it? Possible values of AR, it is -2, and 0 and 16 and 18. Okay. Now, of course, students, if they have more time, they can just do a little bit more, actually go deeper into this concept, and even mathematically they can prove that this is the only answer. We cannot have any other answers. All right, let's move to another question. Question 9. The roots of x squared minus 6x minus 4n squared minus 32n is equal to 0 are both integrals, right? So the question here is find the value of m. Okay, so it is 4, it is n. Okay, it is 9. All right. So again, step by step. So it says that the roots of this equation are both integrals. Suppose that alpha and beta, they are the roots of this equation. Okay. So what can we write here? Alpha plus beta is equal to 6, right? Because b is 6. And out here we have alpha times beta is equal to 4n squared minus 32n. Also here we have minus. So the product of the roots, that's equal to c over a, that is minus 4n squared minus 32n, or simply I can just write this minus 4n n plus 8. Okay, n plus 8. Because a plus alpha plus beta is 6, but we don't know about the sign, right? We have actually infinitely many combinations where the sum of two integers is 6. But actually on the right hand side, alpha times beta, that's equal to minus 4n times n plus 8, right? Okay, what can we do here? We have, I think, nothing to do. We cannot do anything here, since actually the roots are integers, right? How about if we just calculate discriminant? Negative 6 squared, that's equal to 36, minus 4 times minus 4n squared minus 32n. So minus 4n squared minus 32n. So that's equal to 36 plus 16n squared plus 128n. Or even I can just, what is it? 4, it is 9. Anyway, if I just take this 4 out, here we have 4n squared. Here we have 32n, and here we have 9. Okay. All right. All right. So minus 4n, n plus 8, and 4n squared plus 32n plus 9. It should be integer. Okay. So this part, what can we do here? 4 and 2n plus, let's say it is 2n. 2 times 4, it is 8, 64. So it is 8 squared 64. 64 minus 9, it is minus 55. 16, 32, 64. Okay. Okay. Anyway, now if I just write the rules here using the discriminant, what we have here, then alpha will be equal to 6 plus 2 square root of 2n plus 8 squared minus 55 over it is 2, right? And how about if it's beta? Also beta will be, it will be just Also right here, beta will be 6 minus 2 times 2n plus 8 squared minus 55 and over 2. So we can simplify this, right? Actually, when the roots are integer, if under the square root 2n plus 8 squared minus 55 is a perfect square number. So to do this one, then I'll just write here, suppose that 2n plus 8 squared, right? Minus 55 is equal to, let's say, m squared. So m is some integer. Okay, it is integer, means of course positive integer here. So from here I can write this expression then 2n plus 8 squared minus m squared, that's equal to 55, right? Or here we have since actually m is positive, right? I can just write here 2n plus 8 plus m and 2n plus 8 minus m, right? That's equal to their integers, maybe let's say 55 and 1, then here will be 1 and 55. So if it is minus 55, can it be minus 55? Even if it is minus 55, right? Okay, but it should be under the square root positive. Anyway, let's say it is 55, 1 or 155, okay? So now we need to find n here. So if I just add them together, so here we have 2 and 2n, that's equal to 4n. 4n, okay, plus 16 is equal to 51 plus 1, that's equal to, again, actually the sum doesn't change here, it is equal to 56. From here, n is equal to 40 over 4, that's equal to 10. So when it is 10, right, 2 times 10, 20, 20 plus 8, that's 28, and 28 squared, right, this 28 squared is 784, and subtract 55, that's equal to 729. 729 is a perfect square number. So we don't have any other, what is it, number. So okay, how about the thinking, if it is minus, right, if it is minus, at the time here we have 4n plus 16 again, that's equal to minus 56. So what is n here then? Minus 72 minus 18. So one is minus 18, that's also a perfect number, right? Minus 36, minus 36 plus 8 minus 28, and 28 squared minus 55, the same thing, yes. So we have two possible answers now. That's right. Okay, here dot 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 n is equal to 10 or n is equal to minus 18. All right, we have the last question. It's quite challenging question. All values of x1, x2, x3, and x29 are positive integers. One of them is greater than 1988, such that x1 squared plus x2 squared plus x3 squared plus dot 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 plus x29 squared, that's equal to 19 times x1, x2, x3, and x29. They're all multiplied together. Find the set of solution. Let me say at least one solution here in this question. But of course, can we find a solution where at least one of the roots or one root is greater than 1988? But here, for example, immediately we can just think about the first solution. What is it? If all of these numbers, x1 equals x2 equals dot dot equals x29, that's equal to 1, right? Or even if it is 1, for example, on the left hand side we have 1 squared plus 1 squared plus 1 squared, so here we have 29. On the right hand side we have okay, here it should be not 19, It should be 29. Let me correct this. Okay, 29. So on the right hand side, we have 29 times, what is it? 111. So that's equal to 1. That's one answer. One solution is 1, 1, and 1, right? So actually in this way, we can write a lot of solutions, right? Making sure that, for example, even number of roots have the same sign, like let's say minus minus. Here, I can also write here, maybe 27 of them, they are minus signs, and also 2 of them it is plus sign, right? Or 28 of them plus, and 27 of them plus, and 22 of them they are minus minus. Again, I can write a lot of different combinations for this solution, right? And another observation is, suppose that if I just consider this case, suppose that x1 equals, let me use blue here. Okay, x1 is equal to x2 is equal to x28, that's equal to 1. What happens here? Then our equation takes this form. On the left-hand side, 1, 1, 1, 1. So here we have 28, and here we have x. Let me just also label 29. Okay, here, okay, 29 squared, or before I continue, for simplicity, let's say x is equal to x29. So at the time here we have 28 plus x squared. On the right hand side, 29 times 1, 1, 1, 1, and x is x29 is 29x. So from here I can just write here as 2x squared minus 29x plus 28 is equal to 0. So now if you factorize this, here we have x minus 1, x minus 28, that's equal to 0. So here x equals 1 or x equals 28, right? Actually, that means also here we have a lot of different combination numbers, right? Maybe 28, 1, 1, 1, 1, 1, 28, and blah, 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 blah. And in this way, we can get another solution, okay? But here we have, in the question, it's saying that we need to find a set of solutions where one of them is greater than 91988. Okay. All right, so I'll just leave this question unsolved. We are running out of time. Maybe in a separate video, I will share the solution. Thank you.